Excuse me. Excuse me. Sorry, bad form to begin with a cough. I'm back before you, and this is another experiment with my method of X-ray diffraction analysis, which worked fine yesterday. I made calculations, and the with the uh, Fourier series, which is used for X-ray diffraction analysis, and things went quite well. Because I'd used a whole carrot, I got quite a bit of RNA, matching it with DNA. But today it occurred to me to see if really, because I had square waves, rectangular waves, if um, uh, um, RNA is a double helical structure like the DNA. What? All the measurements match with that of DNA. Or at my previous Niels Bohr, Werner Heisenberg experiments, and then my yesterday's experiment. So, but what if they, it is all proof to the contrary, because Francis Crick and James Watson had a tough time proving that it's a double helical structure. So they had data from Rosalind Franklin. They had their own data, and they had to make models, etc., and see. So angles, which I measure, which came to me as a measurement from the calculations. I had to see with a double helical structure, picture of a double helical structure and a protractor. So they match. So it's all good. But what? What if there is? So it's at least a fun thing. So I thought I would make spicy Canadian cookie dough. And this has a couple of flowers in it. Oat flour. Well, my son's coming, but he's coming from Winnipeg. He's bringing the cold weather from Winnipeg to Toronto. Yeah, minus 30s. Toronto is in the minus 30s. And oats, I joked to him, I've shared this with you. You should sow your wild oats. And he had said, you want me to go around having sex? Then my friends used to like this piece of teasing. But he was like, you want me to go around having sex, indiscriminate sex with. So for all the wild oats, he sown oat flour, and the other a cookie dough, a cookie which I made, that also has, but that's sweet. That's a dessert. So this has oat flour and all-purpose flour and some spices, Canadian spices, all the way from Cape Breton. Cape Breton introduced me to these. I've improved them, by adding my own flavor. Being Indian, paprika, chili powder, never far away, or Mexican, that they also, chipotle, the what have you. So let's move this here. Let's set up the, uh, so there's nothing. All right, there's nothing. All right, so a sample I'm taking at the end. Sample, this is a plate from Canadian Tire. And if you want to be successful like my husband, though, during his graduate student and my graduate student days and my son's early days, used to use Chinaware. But my in-laws visited, and after that, he uses only the steel plates. And a microwave is more expensive. It can take metal. Uses only the steel plates that my mother-in-law got. Once in a while, my aunt had given, that to my younger aunt. So these are from Canadian Tire, and I got these. He said these are too big. I don't like these, and one of them I've shared with friends because I baked a cake when I went to their house. So the other one is here, and okay, this is too close. Too close. We will just move this off. Like this. So just in case the plate's not right. So here we go. Back to the microfarads, the inductors, and these maybe a little too small. Alligator clip. Or where did this maybe? Alligator clip. No, I didn't get the batteries again. I didn't get the batteries. The clip. get it clear. I have all batteries, that might work, but I need 4 batteries here. So this and what do I want? I want see things vanish. Okay, this is here. Get a clip. We'll just combine all of these because we need to multiply. That's what this is after. Circuit. Okay. Okay. This goes into here. And let me quickly get the batteries. Bear with me here. We are in this together. Remember the engineers, scientists, mantras, like all the mantras which the Hindus say. So this is the mantra. This is it. We are in it together. This moment of discovery. But typically, I'm told, and I remember from reading, they had this Professor Bulk's course, which dealt with all analytical methods of analysis. I mean, analytical equipment used for analysis, and um, the and we had it included us making a presentation, and oh, so cellophane tape. There must be cellophane tape here. Okay, we'll get. So it. Okay, cellophane tape. Scotch tape. Scotch tape. Actually, this is magic tape. Not even scotch tape. Magic tape. Resistor. Okay. And this is going here. This resistor comes after the battery. Battery can be just something else which makes it easier, I'm thinking, to connect to. This is one. This, but this is a 8 ohms, 0.5 watts. No good, right? So no good. Quickly, bear with me. You're going to ace your connections, right? It's just some waves are coming. Until now I had no The Swarovski crystal. You know, engineers and scientists, they don't need to connect batteries like this. They have receptacles. Uh, we try just to try the black one here. But these have to be connected. See, I'm really becoming tensed up here. I'm losing my thinking capabilities. This Swarovski crystal, it's some waves are coming out, but without power. But an electronic circuit maybe. What would an inductor and a capacitor, inductor, capacitor? The first ones are capacitors. The black is correct. So they're all connected. Uh-huh. Capacitors. Those are capacitors. The farads are capacitors. So capacitors and inductors connected are doing some magic. Oh, this is I should have gotten those, but those are long. Those are no good either. Need to be in. We are in this together. We're going to see if it's FTR, what we get. If FTR, FTIR, sorry, FTIR works. Fourier transform. Fourier transform. Okay. All right. This this we will move this here with. This is the toughest thing, isn't it? Oh, okay, bear with me. I'll get the wires. Bear with me, please. I'm so sorry. So sorry, but in the end result, you know if FTIR works or not. This, so we will just connect the wires. I have so many wires. All right, so the manufacturers, dollars, what passing through their minds. That was a nice terminal, but that was a nice terminal. At all. Okay, so this quickly wires. that could be, what could it be? If they're twisted together, it could be cross current flow, right? I don't want cross current flow. Um, 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 oh, all right. This is a tough one. That's not. This remove this. Oh, it's come off. It is hard. I was blessed when I was doing the electronics experiments because, my um um. Okay. You just need a terminal. Do I need a terminal? I need a terminal. So we just hook this on. What worked yesterday is not working today, but oh, it's really hard, isn't it? We do another scotch tape, cellophane tape. Scotch glasses are not good for experiments, I thought, but and earrings too, right? So this has to be taped here, negative, 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 and positive. With so there's only 0.5. So here, so this is going to be hooked up. How am I going to hook this up? How do you think I should hook this up? What would I do? Take a third wire? A third wire is not such a bad idea. Third wire. Third wire is not such a bad idea. What worked yesterday is not working today. Batteries, maybe we do only 2 batteries. Yeah, 4 is required, but I'm thinking 4 is how much, what radio waves? Radio waves 2 is enough, right? So maybe radio waves, let's see, radio waves frequency radio waves frequency is the gigahertz. Giga is giga is giga is gigahertz, 2 hertz, 10 power 9. So we will just do two batteries because 10 power 9 but we need okay, wait, in parallel, in series would be not right because I need a square on the eye. I need a square on the eye. So a square on the eye needs an alligator slayer, but it's not power squares. So and then black. Black is negative. This is from a Google file. Black's always negative. So I'm hooking this up. This is an insulator. So there's a resistor in this. So an insulator connects to an insulator, maybe a wire. Just here. Insulator. Oh, terminal. 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 This is not one. Oh, it is hard, isn't it? This, let's see if this connects. All right. Okay, this is right. Here. So let's see. Broader bands, broader bands, broader bands than yesterday. Yesterday's was just, but I'm not. I don't even have a sample yet. So let's see. There is. What's this coming out? Oh. Not hooked to that. Yes. Let's see if this. So it didn't measure. Measures only RNA. X-ray diffraction method measures RNA only if there's a really broad band. Yeah, we're generating radio waves now. I couldn't generate radio waves, but you know. This is more pronounced. Do you see this? This is more pronounced. We'll close up. What is that? So I just draw a sketch here and then see if I can explain it. And that's it. That's my experiment. So it's a broadband. First one is a broadband. Oh, measurements. And this is a two band. So maybe I use 3, 4, 5 only. 5 only. 3, 4, 5. Yesterday it was 6. And I just measure. Not having a good day. So FTIR may help because I've uh, broadband, broadband, broadband for 4 inches, 4 inches, 1.5 inch width. The rest are all 1.5. Fourier transform might work. Or these are shorter, 7 inches. Seven. They're becoming broader. This is also becoming broader, but not as broad. So this is not as broad as the first one. This is 6. This is these two are merging. These two are merging. This is a 0.5. 0.5. All right. So something different. So maybe Fourier transform infrared spectroscopy is the right way to go for this FTIR. All right, but well, I did this, and I'm going to see if I get some form of calculations. There's no RNA in this, unless you count chili powder, paprika. All right, paprika maybe. RNA, it's but I had different results for RNA. Didn't get such a broad band. So, starch, oats. So all I ask of you, gentlemen, is to sow your own wild oats and get down to business. Work. Sow your wild oats, just go for a ride or something. Take the subway. Ride the rocket. All right, signing out, Gayatri B. Sitaram. Thank you.